We're doing redox, baby!
What is up, chicken wings and onion rings? It is your boy, Nathan. We're back again. We're going to be doing some redox chemistry. We're going to be assigning some oxidation states to some atoms in some compounds, and I am ready. Are you ready? I feel like you're ready. I feel like I'm ready. I've had a lot of coffee today. Let's go. Okay, so in order to do this, you might be thinking, Nathan, I don't know how to do this. I don't know how to assign these oxidation states to these atoms. That's okay. I got you. We need rules. If you have rules, then you can always do it. You can always figure it out if you know the rules. Let's go through the rules together. Our rule number 1, oxygen is always a -2. Okay? So no matter what we're thinking, oxygen is going to be -2. All right? We good? You with me so far? All right. Hydrogen is a +1. All right? So we're thinking, we never see hydrogen, that's going to be a +1. There are some exceptions. There's always exceptions, right? If we have a hydride, like lithium hydride, where hydrogen is acting as our anion, then it can have a -1. But for the most part, hydrogen is going to be a +1. Okay? You with me so far? So oxygen -2, hydrogen +1. All right, we're good so far. Number 3, ions. Mono or polyatomic are always their charge. So this is especially true for stuff like our group 1 metals, or our group 2 metals, or our group 17 halogens. These babies are always their charge. There are some exceptions also, but usually, especially, those 3 groups like to keep their charge. And same with polyatomics. Polyatomics, you gotta balance it to where it always ends up being the charge that the polyatomic ion is. Okay, we good so far? Oxygen's -2. Hydrogen is +1. Our ions keep their charge with their oxidation state. And the number 4, most important of all, the sum of our oxidation numbers in a neutral compound are equal to 0. So we got to figure out how to zero everything out. That's how we figure out stuff that are not part of our 4 rules. If we can figure out everything else using our rules, we can assign the other stuff, the weird stuff, to make it where it balances out to be 0. All right, so let's do some examples. Let's take our compound with manganese here and oxygen. All right, so looking at our rules, we know oxygen, for every oxygen, is a -2. Okay, so we have 3 oxygens here. This is Mn2O3. So that means we have a -2, and then another -2, and then another -2. And all together, that makes -6. Quick math, okay? So we got -6 on this side. And now we got to figure out, since this is a neutral compound, how to make this balance out. Okay, so in order to get a +6 on this side, we have 2 manganese. What is each of our manganese going to have to be? That is correct. It is going to be +3 for each of our manganese, giving us a +6. So now our overall thing is balanced out. +6 minus 6 gives us 0. And we have our balanced out neutral compound. Okay? You might be thinking, oh, Nathan, that was easy. Good. Because that's a good example. All right, let's do another one. We got iron, we got chlorine. Iron, it's not in our rules. Oh man, but guess what? Chlorine is. Chlorine's our ion that we can use. What is chlorine? Chlorine's part of group 17, baby. So we got to know that it is -1. We got 4 of them. So we got -1, -1, -1, and -1. All together, quick math, that's -4. But before we start go gallivanting off and thinking, oh, we know this, we just got a +4 iron. No. We got a negative charge on this. So our whole thing, our sum of our whole thing has to equal the charge that we're given, since it's an ion. Okay, so we have our iron here. And our iron, in order to get this negative charge, is going to have to be, you heard it, +3. Okay, we good? It's +3 iron. Each of our chlorines giving us a -1, -4. 3 minus 4 gives us our negative charge. Okay, we're good. Moving on. All right, so this is a big old boy here. Let's break it down. First part of our rules. We know that this is also made up of ions. We have a polyatomic ion here. We got our chlorate here. And we have our group 1 from sodium. Okay, so let's take a look. We know our sodium is going to be +1. We know our oxygens. Also, first off, tell me real quick, what's the charge on a chlorate? Right, it's -1. So this is a -1. This is a +1, right? So we're keeping our charges because these are ions. So this is a -1. So we got to make it into a -1. So let's use our oxygens first. Our oxygens are always -2. So we got a -2, a -2, a -2, because we have 3 oxygens in our chlorate. Altogether, that gives us another -6. And in order to balance this out, in order to get that negative charge for our chlorate, what does chlorine have to be? That's right, +5. You might be thinking to yourself, Nathan, doesn't that break our rule up here? The group 17 are always their charge. Kind of, but that's an exception. We got to get our polyatomic ion to be its charge. That's the most important thing. So that chlorine, it can be a +5 if it needs to be. All right. We good? We steady? Rocking and rolling? All right, let's keep going. Stage 3BR, weird example. Let's see if we can figure it out. The only one that we have from our rules, we have 2. I kind of lied. We have 2. Let's start with our hydrogens. So we have 3 hydrogens. We'll get a +1, a +1, and a +1. All right, all together, quick math. You got a 3. All right, what about our bromine? What's our bromine going to give us? Give us a -1, right? Because it's group 17, its usual charge, -1. Excellent. So that means that we have a 3 here and a -1 here. So in order for this thing to come out as neutral, what is our carbon going to have to be? That's right, -2. Kind of weird. But I think if you can figure that out, and if you can figure out the rest of these, you guys are going to be A+ at assigning oxidation states. All right, have fun with this, guys.